Hi, I'm Aditya Gupta, and this is my submission for the Alemeno Backend Internship. My project is built around Fast API, PostgreSQL, Redis, and Celery, and it is designed in such a way that new features don't require organization, and we reduce merge conflicts because there is responsibility separation in our code architecture. For example, fast API routers stay thin and they only validate requests before actually calling the services, while the business logic actually lives in the service layer. For database, I'm using a repository pattern such that the database and the ORM is not tightly coupled with our code, and it can be easily changed later on. Also, I've separated the request response models that use Pydantic from the database models that actually use SQL Alchemy. For testing, the test structure mirrors the application structure, and I'm using a bunch of CI pipelines that include Docker builds, linting, security, and testing. For the request lifecycle, a post request is first uploaded to endpoint, which then validates the CSV. Once it's validated, a job record is created under the DB and it is updated. Then what happens is that API immediately returns the job ID in the same request response cycle, and the transaction is pushed onto Redis as a broker, which is using Redis. The Celery worker is running in its own container, listening onto that queue, and it dequeues a task and performs all of these data processing tasks. For currency conversion, we are using exchange rate client, which caches the fetched data to Redis to avoid repeated external API calls. And for transactions without category, they are bashed and then sent off to Gemini 2.5 Flash Lite. And another thing is that we make another Gemini call to get the summary block. The worker then writes all the clean transactions and job summary into the database, and the job is then marked as complete. Also, to identify the bottlenecks, what I did was I created an observability layer to monitor and perform benchmarks. We can then transition this to Prometheus or OpenTelemetry. What I found was that LLM calls are taking like 99% of the processing time, and even though we are using asynchronous execution, which should decrease the time for this, Gemini ends up serializing API key, serializing requests per API key, so we don't actually see any parallelism. Also, on scale, what would happen is that the Celery backlog would increase and the broker memory would go unbounded. So any calls to the slash status endpoint would just fail. So for the next iteration, one thing that would give us the most gains is to streamline the entire pipeline with something like Kafka and use partition workers. What we're going to do is just replace Celery and Redis broker with Kafka or Red Panda, and so the transaction jobs will be partitioned by the account ID hash, and worker pools would scale horizontally with consumer groups. So what we'll see is that in Kafka, each worker handling the partition would guarantee in order processing, and the 100 jobs that we have, they're only going to take 40 seconds instead of 3000 for if a single job is taking 30 seconds, which we have also optimized in our previous bottlenecks. Another thing is to implement classification cache, which will be stored in Redis, and it will be keyed by this hash function. The cache, in case of a cache hit, there will be instant classification. Otherwise, it will be added to the Gemini queue. This works because even in the database, we saw 40% merchant repetition. So we can expect around 60% decrease in LLM classification time. But one trade-off is that we will have to deal with cache invalidation. Another thing is that in our worker files, we have engine.dispose, which runs on each job. So instead of putting this in each job, we'll pre-pose it to the actual Celery worker. So even if we scale this up, Postgres would not actually refuse the connections. Another improvement that I could see making is to deploy a local model like Gemma using Ollama sidecar in that same worker, so that we have no network latency, which accounts for most of the time it takes for the LLM calls because of the round trip time. And this actually removes the per API key serialization problem, and you would get true concurrency. But the trade-off is that it would take 2 to 4 gigabytes more per worker. Thank you.